Assalamualaikum. Today we are starting the first chapter of AS chemistry, that is atomic structure. So we are going to study about the structure of an atom. Structure of atom means that it's made up of what? And it contains electron, proton, and neutron, and how they are arranged, how the electrons are arranged, where the proton neutrons are, and the electronic configuration, like the whole topic. So if we are starting the atomic structure, your first thing is, I'm sharing my screen. And it is notability. Wait a minute. Yes. Okay, atomic structure. So when I will write, I will share. Now I've shared the screen. I will definitely put my iPad on the table to write. Okay. Atomic structure. The first thing is atom. Right? Atom. Now, atom has two parts. And what are the two parts? Nucleus and shells. I'm using the same words of O levels. An atom contains what? Subatomic particle. What are these subatomic particles? Protons, electron, and I think I should write it like this. Protons, electrons, and neutrons. Now, next point. This is nucleus containing proton, neutron, and these are what? Shells. These are shells. This is nucleus. And these are shells that I'm going to explain in detail. Now, first thing. The electron, proton, and the neutron. Their relative charges and their relative mass. Now, electron, proton, neutron, relative charge and relative mass. Relative charge is -1 and +1. It is 0. Now, you know what is the meaning of the term relative? Relative means compared. You know, one electron is minus 1.6 into 10 power minus 19 coulomb, and one proton is the same coulomb but opposite. The coulombs are same. The coulombs are same. So it's one is -1, the other is +1. What about relative mass? The mass of one proton is equal to 1 neutron, but electron is 1840 times lighter than one proton or one neutron. So how we will write? We write it this way. The electron is 1840 times lighter than a proton, and a proton and neutrons are equal. Now, next point, that atoms contain the positive, the negative, but atom has no charge. You know this pen, this is made up of atoms, molecules, they contain electron, proton, but I don't feel any electric shock. Why? What is the reason? Because the protons are equal to electrons. The positive charge is equal to negative charge. Like if you touch anything like your mobile, your like even the iPad, the table, the chair, and myself, me, I'm made up of proteins, fats, carbohydrates. They are all made up of atoms. Like they contain atoms. Okay, they are molecules, they're big molecules, but they're made up of atoms which contain electron, proton, and neutrons. The electron, protons are positive, negative. Then why there is no current? Like the reason is that positive and the negative charges are balanced and there is no net charge. But if they're not balanced, then they're charged particles, which are ions, cations, and anions. So if there is no charge on an atom, this is a clear-cut indication that the number of electrons are equal to what? Number of protons. Now, the next point is to write atom is what? Atom is neutral. Why atom is neutral? No charge, although it is made up of electron and proton, as number of electrons are equal to number of proton. The negative charge is equal to positive charge. They balance each other. They cancel the effect of each other. Now, next point. Every atom, as you have done in your O levels, every atom has these two numbers to reduce the electron, proton, and neutron. This is your element, huh? And the two numbers, the atomic number or proton number, number of protons in the nucleus of an atom. Mass numbers or nucleon number. Sum of protons and neutrons in the nucleus of an atom. Now, listen. We know that electrons are equal to proton, and this is proton. So if this is proton, the same is the electron. And this is proton plus neutron. So if I subtract proton, I will get what? Neutron. This you have done in your O levels. You know this. Look. Suppose this is sodium. 1123. So this is proton and this is proton plus neutron. There are 11 proton, there are 11 electron, and there are 23 minus 11, 12 neutron. Yes, done. Now, suppose this is fluorine, 919. So, there are 9 proton and proton plus neutron is 19. So 9 proton, 9 electron, 19 minus 9. It's 10 neutron. Done, perfect. Now, we have to discuss how the electrons are arranged around the nucleus. Now, first I'm writing and then I'm going to explain this in detail. This is nucleus containing proton and neutron. This is the first quantum shell. The next right? Now, one thing, I'm going to copy this because I will draw this some 2 to 3 times, okay? So, now, in O levels, what you people study? You people study that this your atom. This inner thing is nucleus, and this is called what? I'm using another color. This is called what? Quantum shells. Now, the one that you were doing in your O levels, they were actually quantum shells. Now, these quantum shells, which are called main energy levels. Main energy levels. These are spherical, not circular. These are spherical. And they are represented by principal quantum number n. The n is, it could be 1, it could be 2, it could be 3, and so on. But when we use such heavy words like principal quantum number, we think that like there might be something different. No, it's the same. Like it's just a name. Look, I'm telling you, wait a minute. Like this is principal quantum number 1. This is principal quantum number 2. This is principal quantum number 3. This is principal quantum number 4. And this is principal quantum number 5. Now, when n is large. The electron get far from nucleus. The electron get less. The electron get less nuclear attraction. The electron is more free to move. Its kinetic energy will increase. Why I am telling this? Look, as we move away from the nucleus, what is happening? As we move away from the nucleus, nuclear attraction. Nuclear attraction decrease. Electron movement increase. Kinetic energy increase. So if the electron is in the first shell, it is in the more in the control of the nucleus. But the electron which is far, it experiences less nuclear attraction. Like it is more in the control of the nucleus, it is less in the control of the nucleus. More control, the movement is less. Less controlled, the movement of the electron is more, automatically its kinetic energy is more. So if the electron is getting far from the nucleus, the electron movement is more, the energy is more. So when the electron is in the principal quantum number 1, it is in the first shell. Electron in the principal quantum. Okay, they use this word, the principal quantum number terminology. I can even show this to you. Look how they use this. Atomic structure. So this is your paper 2. Let me show you this. Come. Look at this. Look at this question. So how they use this word, the principal quantum numbers. Look. It has highest energy of the orbital with the principal quantum number 3. So what is the meaning of this? In the third shell. Orbitals in the third shell. That's it. It's not just once. Which atom has outermost electron in an orbital of the shape shown with the principal quantum number 3. What is the meaning of this? Third shell. That's it. Actually, in Cambridge, in an Edexcel, in Cambridge and in Edexcel, we discuss what? We discuss distance of electron from nucleus, energy of electron, spin of electron, orientation of electron. Like we talk about electron in an atom. The electron is at how much distance? Electrons have how much energy? The electron is spinning clockwise, anti-clockwise. Is the electron moving like this or moving like this? And what is the orientation? Is the electron revolving around along x-axis, along y-axis, along z-axis? Like we want to discuss that how the electrons are moving. They have, what are their energies? What are their spins? When we discuss all these, there are 4 quantum numbers that the students in FEC study. Like there are 4 quantum numbers in the matrix system. There are 4 quantum numbers. There are four quantum numbers to describe all these. One is principal quantum number, one is azimuthal quantum number, one is magnetic quantum number, one is spin quantum. Like what are these quantum numbers that I wrote? The quantum number discuss what? The distance of the electron from the nucleus, the energy of the electron, the spin of the electron, the orientation. Like we do all these without naming anything except the principal quantum number. But in metric, you have to study the name and everything along with the concept. So, like, sometimes you find that these things make chemistry more hard. Otherwise, like, the understanding is the same. It's the same understanding in both the system. But even if you don't know about the word azimuthal, it's not going to affect your chemistry. Do you get my point? Even if I don't say that principal quantum number 3, I think it's not going to affect the student right in A levels or in matric or in FEC. Yes, maybe when you are going to study the quantum mechanics, when you have to study Schrodinger wave equation, wave mechanical model of the electrons, then I think these things bring a difference. But at this point, it's okay if even if I say that this is first shell, this is the second shell, the third quantum shell, even without studying the principal quantum number word. Do you get my point? So coming to this. So this is nucleus containing proton, neutron, and these are electrons which are present in these shells, and these shells are represented by this number, which is called principal quantum number, which means that third shell, the second shell, the first shell, as you go away from the nucleus. The nuclear hold is less, the electron movement is more. Next point. If you look, this distance is more, then less, then further less and less. It's actually like this. This we will study in the next topic, or yeah, like in the coming lecture, or maybe today. I don't know that when we will reach at this point. But first thing, that how these electrons are in these quantum shells. Next point. The quantum shells contain subshell. Quantum shells contain subshells. There are 4 subshells. S, P, D, and F. Quantum shell contains subshell, S, P, D, F. You know, subshell S contains 2 electrons, subshell P contains 6 electrons, D have capacity of 10 electrons, and F have capacity of 14 electrons. You know what actually we are going to study? In an atom, listen, this is nucleus, these are electrons. They're not necessary to be in these spherical things, spherical roots. Around the nucleus, the electron will try to be as far as possible. They don't get close together. The electron in an atom, the electron try to be as far as possible from each other. Why? This is nucleus. These are electron. Do you think the electron attract or repel? They repel. Would they try to get close, or they will try to be as far as possible? As far as possible. You know, suppose this is a home, a house. Sorry. In this house, there are rooms. So when I ask you that where do you live, definitely you will say that I'm living at this place. Like for example, uh, we want to find out the exact position of an electron in an atom. Like suppose if I want to find out the exact locality of a person, I will ask him that where do you live? And his response would be definitely that I'm living in Islamabad. Okay. If someone tell you that he is living in Pakistan, in the whole world, like if you know that he is living in Pakistan, the probability to find that person is like quite more. Like if you don't know that he is living in Pakistan or he is living anywhere, like you don't like you can't find that person easily. But if you know that he is living in Pakistan, you can, this shows that you can find him, certain probability. But if he says that I'm living in Islamabad in Pakistan, probability increase. Now, if he says that in Islamabad I'm living in G9, probability increases further. In street, this, probability more. In house, this, further probability increase. Like even if you know about the house, if I tell you that he is living in this room and he is right now lying in the bed, the probability to find that person is maximum. So actually what we are trying to find, electron. If I know that electron is in the third shell, right? In the third shell or in the second shell, right? Probability is more. Now, if in the second shell, it is in S subshell or in P subshell, like even if I know about the P subshell and if I further know that it is P, it is in P and it is moving like this along X or along Y, the probability will further increase. We are trying to find the probability to find the electron in an atom. And secondly, why the electron is along x-axis or y-axis or z-axis, or it is in S or it is in P or it is in D. Why? Why they're not at one place? Because they repel each other. They try to be as far as possible. They get scattered. They're not at one place. They're held by the nucleus and they're trying to go away. There are centripetal. There are centrifugal forces. The laws of the circular motion, they totally applies on this. Like, it's such a huge topic. Like electrons are not like this, the way you have studied in your O levels, moving like this and 2 and 2. No, they're not like this. No, they're like this. Nucleus, this is S, this is 2S, this is 2px, this is 2py, this is 2pz, this is 3s, this is 3px, this is 3py, this is 3p. Like why this thing? Like what am I doing? I'm showing the electron that how they are revolving around the nucleus, but since the electrons are negative, they try to be attracted more by the nucleus, but they are trying to be as far as possible from each other to minimize repulsion. Therefore, the quantum shells contains what? Subshells. They have some spaces. They are not scattered. They're not roaming around everywhere in the atom. No, they have their particular roots and places where they are spinning and revolving. So next thing that I want to tell you, wait a minute. There are how many subshells? There are how many subshells? 4 subshells. There are 4 subshells. The capacity of the S subshell is 6, no, is 2. The P is 6, the D is 10 and 40. Right? I'm going to explain all these. Wait a minute. In A's, we will do these two. In A2, we will do D, and we are not going to F in A levels. Right? Now, this is S. How many electrons are there in the first shell? Just 2. And the 2 electrons both are in S. How many electrons are in the second shell? 8 electrons. In the first shell, just S. For 8 electrons, one S and one P. S and P. 2 electron in S, 6 electron in P. What about D? Where it comes? What is the capacity of the third shell? How? 2 electrons will be in S and 6 electrons are in P and 10 electrons are in D. 18 and 4 and 4. Look. 2 electron in S, 6 electron in P, 10 electron in D, and 14 electron in P. It's how much? 18 plus 14. It's how much? 32. Sure? Yeah, 18, 32. Yes, 32. We actually don't need it. I'm just 32 electron. Now, in the fifth, it's exactly the same. No difference at all. No difference. 2 and 6 and D and 10 and F40. Now, next point. There are 2 electrons in the first shell. That would be in the S. There are 8 electrons in the second shell. Out of 8, 2 are in S and 6 are in P. I've told you the atom is just like any house. In a house, the people live in particular places. Right? Like 2 electrons in the first, 8, 2 in S and 6 are in P, like capacity of 2 and suppose this is 6. Huh? And 18, 2 in S, 6 in P, and then 10 in D. Now, next point that I want to make it clear is this is S of the first. So what you will call it? 1S. This is S of the second. So 2S and 2P. This is S and P and D of the third. This is S and P and this is S and P and D and F of the fourth. And what about the other one? This is what? 5, 5, 5, 5. Do you get? Look. Quantum shell contain what? Subshell. Right? Quantum shell contain subshell. The first quantum shell contain 1s, the second contain 2s and 2p, and the third contain, like the 18 electron, the 8 electron, they're not scattered. They're in their particular places, which are subshells. But you know, subshell contain what? Orbitals. I'm not going in the detail. These SPD, these are spectroscopic terms. These are derived from the spectrum, the series that they get. They obtain the spectrum and they pass radiation. Like these are sharp, these are principal, these are diffuse, these are fundamental spectral lines after spectroscopy. So like there is too much inside it, and we are just doing it according to our class, our syllabus. So subshell contain what? Orbitals. Quantum shell contain subshells. Subshell contain orbital. You know what is orbital? You know what is orbital? Region around the nucleus where probability to find electron is maximum. Region around the nucleus where probability to find the electron is maximum. Right? Now, next point, every orbital accommodate only two electrons, only two electrons. The two electrons are spinning opposite to minimize repulsion. Orbital is represented by a box or dash. At every orbital, how many electrons? Two. One clockwise, one anti-clockwise. Why? To minimize repulsion. Spin clockwise. Spin anti-clockwise. Spin clockwise and spin anti-clockwise. Now, next point. What we have done? These are quantum shell represented by principal quantum number. Quantum shell contain what? Subshell. The first quantum shell is just S subshell. The second quantum shell has two subshell, S and P. But the subshell contain what? Further orbitals, where probability of electron is maximum. Now, one thing that I want to clear. This is subshell, and this is what? Orbital. You know, S subshell and S orbital are what? Same. There is no difference. It has a capacity of 2. It has the capacity of 2. It is represented by one box containing how many electrons? 2 electrons. Now, can you tell me how much should be the orbitals in p subshell? It contains what? 3 orbitals? How many orbitals? 3. Why? Because there are 6 electrons. 2 and 2 and 2. So there are 3 orbitals inside this p. So if there are 3 orbitals, one is called px along x-axis, one is called along y-axis, py, and pz. Like they're the same thing, but one is along x, one is along y, one is along z. So it has 3 orientations. So we will represent this by how many? 3 boxes. One is px, one is py, 2 electron, and 2 electron, and 2 electron. 6. Now, can you tell me about D10? How many orbital? 10. So 2, 2, 2, 2. So how much? 5 orbital. We are not going to name it in ACE. In Excel and in Cambridge, it's the same thing, right? we don't study these d orbital in AS, we will do this in A2. So 5 orbitals. How many boxes? Definitely 5 boxes. 1, 2, 3, 4, 5. And there are how many electrons in each? 2. Clock and anti-clockwise. And what about F14? These are how much? 14. 2, 2, 2. So 7 2s are 14. So 7 orbitals. Right? 7 orbitals. So if there are 7 orbitals, if I show you one thing, wait a minute. Look, how do we write? What is written? Oh, this one is not good. Look, like we have to do this type of configuration. Our main target is this thing, right? Now, 1 is to 2 is to 2p6, 3 is to 3p6. Like what? This is S of the first, this is S of the second quantum shell. So in the first quantum shell, 2 electron. In the second quantum shell, 6, 7, 8. In the third quantum shell, how much? 3, 4, 5. Do you get? 1 is 2, then 2 is to 2p6, second shell, then 3 is to 3p6, 8, and then fourth quantum shell. We are actually moving toward this side, but we have to study all these properly in detail. So coming to this. So 7 orbital, and our target is krypton, right? Krypton 36, right? Krypton 36 is like in the core, the configuration up to Krypton 36 is in your course, right? So we don't need to do for F, like even I don't want to draw the 7 thing, like it's just taking time. Okay, now coming to orbitals. One thing that I want to clear. You know, the S orbital and S, how are their shapes? Look, the S is spherical. It's a 3-dimensional thing. Spherical. Accommodate 2 electrons. Accommodate how many? 2 electrons. Now, what is the difference between 1s, 2s, and 3s? The only difference is it is close to the nucleus, it is far, and it is further far. So this is it's like this. 1s and then 2s is a big sphere, and then 3s is a big sphere. Spherical. Look. First, X, Y, and Z. Oh, no. Now, look. This is 1s, small sphere. So the 2s and 3s, how they are different? They are all different from each other. Just in the size. The 2s will be bigger. Why? Because it is in the second shell. It is in the second shell. And it is in third. So it's much bigger. The only difference, the capacity of like the 2 electrons are moving in a sphere, but they're closer to the nucleus, they're far, and they are further far. Now, how is P? You know, P is P orbital. It is dumbbell shaped. You know, a dumbbell could be along x-axis, y-axis, and z-axis. I'm using the word orbital, not subshell. The orbital have 2 electron capacity. The dumbbell shaped orbital has capacity of 2 electron in each p orbital. P orbitals has 3 orientations. How? No, can I? What I'm doing great. Yes, good. So the p orbital, which is dumbbell is like this. So a dumbbell could be along x-axis, a dumbbell could be along y-axis, a dumbbell, and each is having how many electrons? 2. So if it is along x-axis, it's called what? Px. Along y-axis, called py. Along z-axis, called pz. Look, px, py, and pz, each is having how many electrons? 2. 2, 2, 2. So total how much electron? Total how much electron? 6. Right. Now, I want to show these to you. Wait a minute. Wait a minute. This is what? 1s. This is what? This is what? 2s. 2p. This is what? 3s. 3p, 3d, and then 4s like this. So, first, roughly, this is nucleus. This is nucleus. This is 1s spherical. And after this, 2s, 2px, 2py, and 2pz. Look, 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 look. First, 1s, then 2s, then 2px, 2py, 2pz. After this, what? 3s, 3px, 3py, 3pz. Why the electrons are doing like this? To minimize repulsion. They're trying to be far from each other, but close to the nucleus. So it's like this. Now, if I draw it properly, it is nucleus. It is 1s. This is what? 1s. Now, this is 2s. Any atom, like sodium. 2s, and then 2px, 2py, 2pz. Look, sodium has 11 electrons. Out of 11, 2 are in this, then 2 and then 6. It's how much? 10? 4, 5, 4 plus 6, 10, and 3 is 1. This is sodium. So sodium has configuration what? 1s2, 2s2, 2p6, and 3s1. 2, 8, and 1. 2, 8, and 1. Right? 2, 8, and 1. This is nucleus, 1s, and then 2s, 2px, 2py, and 2pz. After this is what? 3s. And after 3s comes what? After 3s comes 3px. Oh, what I made. Sorry. This is what? 3px. Then this is 3pz or 3py. They're all perpendicular to each other. Oh, sorry. Do you get? So the electrons are revolving, spinning like this and this and this. They're trying to be as far as possible. I'm showing a video, the configuration, like just to see the S and P, like how can you imagine them, right? Wait a minute. Here should I? Wait. Yes. Shape of no shape of d orbital. Sorry, configuration of electronic configuration of scandium. Yes. Look at this. In this video, there is no sound. This is look. This is what? 1s. This is what? 1s. 2 electron in 1s. Then it is what? 2s, spherical, a bigger sphere. First it was 1s and then 2s. And now look. Actually, the 2px, the 2py, and 2pz, they're all perpendicular, and they should come at the same time. But they're sending the px and py separately. And it seems that they're separate. No, they should come at the same time. But it's okay. It's a good video. Then now it's what? 3s. Now I'm going to repeat it again. Look. This is 1s containing 2 electrons, spherical, small sphere, close to the nucleus. After 1s, then it's what? 2s containing 2 electrons. And now 2px dumbbell along x-axis. Then 2py. Then 2pz. The 2px, 2py, 2pz, they're all at the same energy, same distance from the nucleus, 2p. Now 3s far. And now look, 3px. 3py. And 3pz. And after 3, we are expecting 3D, but it's actually 4s. Look. 4s. This we will discuss. And now look, the 3D are in A2. They're not in our course. They're quite different. The blue ones, they have 4 lobes and like they're quite different. The F are even much more complicated. So the d orbital shapes and everything are in A2. So I'm stopping this. Now look. Students, students, I think you understand that, okay. Okay, now I think you get the idea of SPD, that these are orbitals, subshells, and quantum shells, and then next topic is electronic configuration, how to fill this properly for sodium, for potassium, for all, for first 36 elements we have to do. And after 36, you will be able to do it for anyone. And secondly, I will teach the configuration by 2 methods, using periodic table and even using Abba principle, right? We will do these 2, okay, in the next video. Okay, Allah Hafiz, take care.